Okay, the water cycle. This is what we're learning about this week, 7s and 8s. The water cycle is something that you've seen before. It's pretty complex or pretty simple depending on how deep you go into it. And this year we're going to take the water cycle a little farther. So what I've drawn on this picture here is a whole bunch of different things. I'm not a great artist, so you're going to have to try to follow along with me. Can you back up a little? All right, I've got my handy dandy camera woman helping me out today. So this is our water cycle. And it has a whole lot of stuff. We've got the sun, which drives the entire cycle. I've tried to draw a surface lake with a river running into it. I've tried to draw a hill with some trees and grass and a deer. And then I tried to show you kind of a cutaway version of what it would look like if we sliced into the land and went deep underground. And you can see that there are different layers of rock, and I put in a well, and then I go down a long way to a layer of rock called an aquitard. There's a mountain in the background with snow, and there are clouds in the sky. And I'm going to take you through the water cycle. The water cycle, like any cycle, is a circle. You can start anywhere, but I'm going to start with the sun. So the sun shines on our earth, and that radiant heat energy warms up our earth. Liquid water, if you recall, as long as it's above zero, can evaporate. What that means is the particles of water vibrate faster and faster as it gets warmer. And those liquid particles at the surface, every now and then, there's a combination of bouncing, which will bounce one of the particles off, and it will zoom away from the water as a gas. And it will travel through the air until it slows down as it gets higher and higher, where it's colder and colder, and that particle slows more and more until it hits another particle. So we start with radiant heat energy from the sun. Radiant energy. And that water, or that energy, warms up the liquid water. And what we get from surface water is something called evaporation. Evaporation is the name that we give to any liquid turning into a gas. Now the water evaporates, we can't see it. There's no way for me really to show you water gas on the diagram, but you just imagine it. And as it goes higher in the air, it coolers and it condenses, condensation, which is the name that we give any gas when it slows down and turns back into a liquid. We call that condensation. So radiant energy evaporates water. Water recondenses into clouds. As soon as you can see a cloud, you know it has to be liquid water. Now as those drops get larger and larger and larger, they get heavier and heavier and heavier. Gravity pulls on them more. And eventually the wind currents can't hold those drops of air up or drops of water up in the air anymore, and that water falls back to earth as something that we call precipitation. Now precipitation can be sleet or snow or rain or hail. It can be anything. I tried to draw some snow falling, and if it's water, it's going to hit the ground. It does a couple of things. One, if there's a lot of it, it'll just run over ground. It's something that we call overland flow or surface flow. And that'll just run into creeks and rivers, and it'll go back into lakes, and we'll go back into the cycle again. But if you get a lot of water falling, it'll drip into the soil. Now trees and plants will use it, and they'll suck that water up through their roots, and that water will evaporate off the trees and plants. And we call that transpiration. Transpiration. But if enough water drips down through the soil, it'll percolate down through the layers of rock. And it'll keep going down, pulled by gravity, until it gets to a layer of rock it can't get through. Layers of rock underground, if they're sedimentary rock, will be things like sandstones or shales or gravels. But every now and then you'll get to a layer of rock that's made mostly of clay. And when the water gets to it, it can't percolate through the clay. And so it just piles up on top. And you get a layer of really, really wet rock on top of that layer. So the layer of rock that water can't get through is called an aquitard. It's Latin for aqua, which is water, and tard, which means slow. And so it can't get through the aquitard, and it piles up. And we call that the saturated zone. It's the zone of rock that's really wet. Now, eventually you'll get to a point where it's not saturated anymore. We call that the unsaturated zone, where the rock is relatively dry. Now, if you dig into rock, as soon as you get to the top of the saturated zone, which we call the water table, you'll notice water starts flowing into your hole. So that's what wells do. We dig a big hole straight down into the ground, and water from the saturated zone will soak into our well, and we can pump it out and use it for all sorts of stuff. You've done this before. If you've been at the beach and you're sitting right here by the edge of the water and you dig a little hole into the sand, you'll notice there comes a point where the water starts flowing in from below the sand and the sides of the sand. Well, you're at the level of the lake there. you're really close to the lake, so you don't have to dig far down to get to the water table at the beach. But if you go higher up away from the lake, you have to dig a lot farther down to get to the water table. Now, the more rain that you have in an area, the higher your water table is going to be. And so these levels in the well can go up and down throughout the season depending on how much rain. And the water tables will be the same level as your lakes. So the water cycle. Radiant heat energy from the sun evaporates surface water. That evaporated water gas goes into the air and it slows down and cools and recondenses into clouds. Those clouds fall as precipitation. When the precipitation hits the ground, it either trickles over ground and goes as overland flow or surface flow back into the lake, or it gets used up by trees and grasses as transpiration, or it trickles through the layers of rock down until it hits an aquifer and it fills up what we call the saturated zone. Now, Guelph has this. Guelph uses, like all of our drinking water comes from wells. We have layers of rock underneath Guelph that hold a lot of water. We have a huge aquifer under Guelph. An aquifer is a big chunk of rock that holds a lot of water. Ours is called the Annabelle Aquifer, and it's a little more than 50 meters down. It's a long way down. And if you drill holes into our aquifer, we can suck water out. The problem is, if you take water out of the aquifer faster than the water's going back into the aquifer, your level's going to drop. Just like a bathtub, if you've got the drain open and the water running out of the tap, if the water's coming out of the drain faster than it's going into the tap, your bathtub goes lower. And so what happens to Guelph's aquifer is, as each new person and each new house moves into Guelph, they start paving over land. And when you pave over land with a parking lot or a house or a roof or a driveway, what happens is when it rains, that water can't get down to the aquifer. It goes to the Grand River or it goes to the Speed River and out to Lake Erie. So every house in Guelph takes away some of the land that the water can percolate down to our aquifer. As well, every house in Guelph wants to suck water up for their showers and their dishwashers and their pools, and that takes water out of our aquifer. And what we're finding is that over time, as more and more people come to the area and we use more and more water, as the level of our water table is falling, and we have to dig our wells deeper. And then if you have companies that use the same water, for instance, Nestle Water uses water out of our aquifer. They like to use water just like we like to use water, and every time you pump water out of the ground, there's less in there for a long time. But that being said, the Annabelle Aquifer is monstrously huge. Well, we've probably got hundreds of years before we drain it too far. We still should be careful on how we use any resource, including water. So that's what we're learning about this week, the water cycle.
Hey grade 8s, listen to that. Frogs. I'm out at a drainage pond behind some houses. The swallows are all over the place here. It's kind of cool, but you can hear the frogs singing. They're trying to find each other to make more frogs. But I'm out here specifically today because it's gonna rain. You can see a lot of liquid water up in the sky already. Clouds are liquid water. This is liquid water. And what's happening is the sun is shining on our earth, as it always does, and it is warming up the earth. Now, liquid water can evaporate. I want you to think about our lesson last week of what is water, and think about what water molecules look like in liquid form. They're close together and they're moving and they're bouncing off each other, and every now and then a liquid water molecule can break away from the other ones and go off into gas form. It's called evaporation. Now, when water goes into gas form, we can't see it. It goes up and up and up into the sky, and it moves around and cools down until it finds some other gaseous liquid or gaseous water, and they collide together and stick. If they're moving slow enough because they're cold enough, they'll stick. And when billions or trillions of them stick together, they form a tiny droplet. And if you get lots of those droplets in an area, you see it as fog or mist. And if more and more congregate and those droplets get bigger, we see them as big fluffy clouds. And then if those clouds get bigger and more liquid water drops condense and turn into bigger drops, we get dark clouds. So the sun evaporates the liquid water into gaseous water. The gaseous water goes up into the sky and slows down and clicks onto other water molecules, condensing into liquid water. And then when those drops get big enough, they get dark. And then the drops get heavy enough, they'll fall back to Earth. Now, when they fall back to Earth, we call that precipitation. Now, precipitation can be snow or sleet or rain or hail. But when it falls back to Earth, it lands either on the ground or in water. If it lands in water, it's super simple. It just goes back into the cycle. If it lands on the ground, it does one of a few things. One, it can stay in the dirt and the mud until it evaporates. It takes a little longer that way, but it'll still evaporate. Two, it could be used up by these organisms, plants. the roots of plants will suck up the water and the water will evaporate out of the plants. We actually call that transpiration. So the water goes from the surface water, condenses into clouds, falls as precipitation, lands on the ground, gets sucked up by plants, and is used as evaporated off as transpiration. But if a lot of water falls on the ground, what happens to it? Think about the water that's underneath this pond. Some of it will be leaking down into the soil underneath. If we dig a hole right here, what we'll see is that liquid water will be not too far. I got a stick and I dug a hole in the ground. You can see how there's water down there. Well, where did that water come from? It's slowly trickling in from all around. If I dig any deeper, it'll just get wetter and wetter. Well, it comes from here. It's coming from the pond. The soil underneath and around the pond is very wet, and if I dig down into the ground at about the same level as the pond, I'm going to find liquid water. Now, if I walk farther up, away from the pond, and I dig here, I'll have to dig deeper to get down to that liquid water. It's called groundwater. There's water under most of the ground. As long as you've got soil or sedimentary rock under you, you'll probably find water under your ground. So when the precipitation falls back to the earth, it either gets used up by the trees, or it trickles along the top of the ground and back through streams and rivers into a local water body, or it evaporates out of puddles, or it soaks through the soil and goes underground into the groundwater. It's called the water cycle, and that's what we're going to learn about this week.